this should be the last video for this lesson. We are at number 14, and number 14, these are just for reference. I think you've used it before in your trigonometry / pre-calculus classes. Sine squared plus cosine squared is equal to 1, so those identities. Will we see this in AP Calculus? Maybe 1 or 2 of your homework problems will require you to use this, but on the test, on the practices, on the previous exams, I have never seen us having to use these identities to be able to solve a problem. You probably could, but it was really not needed. I mean, really, these are a little bit more important than the identities, okay? So again, I just want to spell it out. CSC is cosecant. And the definition for cosecant is 1 over sine. So these are reciprocals, not inverse, reciprocals, okay? Not inverse. They are not inverse functions, okay? Secant. Secant is 1 over cosine. Cosecant is 1 over sine. And then this is cotangent of x. That's going to be 1 over tangent. All right. When you guys, when we do all students take calculus, and I'm just going to put this on number 14 on the side over here. Well, how would the other 3 play as well when we are trying to evaluate some of these functions? So all will represent all 6, okay? So all 6 is going to be positive over here. So sine, cosine, tangent, cosecant, secant, and also cotangent. But when it says S over here, we're also going to use the reciprocal. The reciprocal will also work in the same way. So sine is positive as well as its reciprocal function cosecant. Okay, so sine and cosecant both are going to be positive in the second quadrant. So that means that not only tangent is positive here, but also cotangent is positive on the third quadrant. And then cosine is positive over here, but not only that function, but also secant, its reciprocal function. Okay, so cosine, cosecant, and all 6 in quadrant 1. I kind of want to go over a couple things because, you know, sometimes like we see this and then, hey, wait a minute, isn't cosecant the same as sine to the -1 of x? And the answer is no for this one, okay? I do want to remind you guys, cosecant, and I'm just going to copy and paste from what I see from number 14, is sine of x. This is a reciprocal. Okay. When we use sine of -1x, this over here is like, it's not like, it is asking like what the theta is, asking for the angle. And actually, I'm going to improve some of the notes after this. So say, for example, like we have something like this. Pi over 6, pi over 3, 1, 2, square root of 3. Okay. And then we're left with this. So we're asking for the angle. So what we actually did, and I missed that step on our first video, and that's totally fine, is actually in the middle of this, we were supposed to write sine inverse sine, or arc sine. Okay, this is arc sine, or inverse sine of 1/2. So we were supposed to have written this on the first part, but that is okay. So it's actually asking what that theta is, asking for the angle, and then we put down the angle that we think it is, okay? So it's asking for the angle. So in stuff like number 2 and number 5, we could add that in. So on number 2, if you have some space, you can put this in, and if you don't have space, don't even worry about it, okay? So really, what we're trying to do over here is I'm going to put theta over here, then I'm going to put arctan of -square root of 3. Then it's asking us, okay, what is that angle? Then we can do all of this. Oh, those two angles are 2 pi over 3 and 5 pi over 3. Okay, so it is just to clarify, okay, they are not the same, okay? Cosecant is 1 over sine of x. It's a reciprocal function. But if you see arc sine, sine to the negative 1, it is asking for the angle. Okay, dot, dot, dot. All right. But wait, in algebra 1, didn't we agree that x to the negative 1 is equal to 1 over x? And I'm going to give you 2 answers. It's going to be yes, and it's going to be no. Okay? It's going to be yes for variables only. So say, for example, we have like, a, b, c to the negative 1, and then c is the only one that's to the negative 1, then we put that underneath, so that's going to be ab over c. So if it's just strictly variables, that's totally fine. But it's going to be a no for functions. Okay. F of x is not the same as f to the negative 1 of x. It's inverse. Okay, so this is an inverse. And I can probably show you guys that this right now. So here's like maybe like a small proof, I guess. Here, let's just kind of define f of x a little bit. I'm just going to make this up. Let's just suppose that f of x is equal to 2x. Okay, so if we were to do a reciprocal function, so 1 over f of x, that's equal to 1 over 2x. Okay, so that's that. All right. If we were to do inverse, so what's going to happen is I'm going to write this as y is equal to 2x. To find the inverse again one more time, and if you don't know it, it's totally fine. We're going to switch the variables. X is equal to 2y, and then after that we're going to solve for y. So I'm just going to divide both sides by 2. Then you have 1/2 x is equal to y. Notice how these two are totally different. The x over here is at the bottom. The x over here is on the side, or technically on the top. Okay, so these are not the same. Okay, so please just be careful. Really, the point of that questioning is this part over here, Isn't cosecant x the same as sine to the negative 1x? The answer is no, okay? Cosecant is 1 over sine. It is a reciprocal function of the sine function. If you put sine to the negative 1 of x, it is asking for an angle, and the real name for that will be arc sine, okay? It is okay for variables, but it is not okay for functions. We will do inverses a little bit later as well, when we get into that chapter of inverses. Okay, let's go draw the reference triangles over here, and then we'll do some of these evaluating some of the functions, and we're pretty much done with this video. Okay, let's just draw our reference triangles here. Apologies, this is supposed to be the 45, 90. It does not look like it. I'm sorry. Pi over 6, 30 degrees. Pi over 3, 60 degrees. 1, 2, square root of 3. Okay. I think I want to do 18 and 19, definitely. And then probably like 4 to 6 more. Okay. All right. I've also added these in. Cosecant, you can see that it is a reciprocal because sine was opposite over hypotenuse. Cosecant is hypotenuse over opposite. So just as a small reminder, secant is hypotenuse over adjacent. Cotangent is adjacent over opposite, whereas tangent was opposite over adjacent. Okay, so these are reciprocal functions. They're not inverses. Let's start with this one over here, cosecant of pi over 4. For me, because this is a reference angle in quadrant 1, I just kind of just use, our reference angle over here. And remember, cosecant is hypotenuse over opposite. So here's pi over 4, hypotenuse over opposite. So that's square root of 2. Square root of 2 over 1 or square root of 2. Okay, so that's that. Okay. Number 19, now we have this part, and I want to go back to the notes from the previous lesson because I just kind of want to write this one down. Okay, so step 1, I'm going to use my reference angle. Our reference angle was pi over 4 because this is all over 4. And we have already done the work. Cosecant of pi over 4 from number 18 was square root of 2. Okay, so I'm going to evaluate using the reference angle and see what that answer is. Okay. Now let's just kind of figure out where this is in its quadrant. 3 pi over 4, if we follow our odds patterns, it's 1, 3, 5, 7. So this is in quadrant 2. Okay. All right, step 3. In quadrant 2, and I'm going to go all the way up to number 14 because I drew it. In quadrant 2, only sine and cosecant are positive in this. Okay. Only sine and cosecant are positive. And that's good for us because when we evaluate this, cosecant of 3 pi over 4 is going to be still positive square root of 2, just like number 18. Because it's in quadrant 2, and in quadrant 2, sine and cosecant are positive, we're going to leave it as positive square root of 2. Okay? If this angle had been in quadrant 3 or 4, then this would have been a negative square root of 2. Okay, so that's that. So we're really just following the patterns of how to evaluate this from the previous video. It's just that now we have these other 3 functions to deal with: cosecant, secant, and cotangent. Let's go move on to a couple more. 34. Yeah, let's do 34, 35. Yes, yeah, 30. 34, 35. And I think I want to do 3 more after this, and then that's it for this video. Okay, so let's do secant of pi over 6. I hate that this computer program does not put parentheses. I kind of want that parentheses. Okay, secant is, and I do want to remind you guys, secant is hypotenuse over adjacent. Because it's a reference angle, I'm just going to use, because it's an angle that's in quadrant 1, I am just going to use our, I'm trying to find our reference triangles on number 17. Okay, so pi over 6 is 30 degrees. And we had said that it is hypotenuse over adjacent, okay? So it's going to be 2 over radical 3. So this is going to be 2 over radical 3. You actually could technically leave this. They will not mark it. I know some of the algebra 2 rules is you're supposed to multiply top and bottom by the radical. If you had left it as 2 over radical 3, you would have been okay with that. But I know some of you guys are used to this, so I'll just keep at it with this. Radical 3 times radical 3 is 3 on the bottom. Okay. All right. So it's going to be 2 over radical 3. 2 radical 3 over 3. And that's it for that. Okay. All right. 35. So secant of 11 pi over 6. Good thing it's an over 6. So we already know the value of the reference angle if we evaluate the secant. Okay. So I'm just going to do step 1. At least we know secant of pi over 6 is 2 radical 3 over 3. So that's good to know. Okay. 11 pi over 6 is in what quadrant? So remember our pattern. At 5 p.m. I went to 7, 11. 11 is in quadrant 4. Is in quadrant 4. Let's go take a look at quadrant 4. Quadrant 4, all students take calculus. Only cosine and secant are positive. So cosine and secant are positive. So therefore, secant of 11 pi over 6 is equal to, we're going to leave it as positive 2 square root of 3 over 3. Again, if this would have been an angle that was in quadrant 2 or 3, okay, like maybe this was 5 pi over 6, which is right over here, then this would be negative 2 radical 3 over 3. Okay, so that's how that answer is going to change. I think I want to do maybe some of the later problems, and that's it for this video and this lesson, really. I think you should have enough to go along with. Okay. Okay, I know what I want to do. I think I want to do these 3, 57, 59, and 61. Whenever we're doing the 90 degrees, the 180 degrees, the 270, you know, the angles that are on like the X and Y axis like that, I usually try to use the definitions. What I mean by this is I'm going to do the definition of 1 over sine of pi over 2, because that is what cosecant is. So anytime like I see like 90 degrees or 0 degrees, 3 pi over 2, I try to do definitions like this. Okay. All right. Well, sine of 90 degrees is 1. 1 over 1 is 1. Okay, cosecant of pi over 2 is equal to 1. All right. Cotangent. So again, this is what I mean. For cotangent, I know it's cosine over sine. So, and then I'm going to evaluate that. And I think there was a good reason why I did it. I think on some calculators, if you kind of just input it, I think it'll give you a wrong answer. I don't know. You know what? Let's just go check the TI-84 just in case. Okay. But anyway, so I just do it this way. Cosine of 90 degrees, I know is 0. Sine of 90 degrees, well, that was from number 57, so that's 1, and then that's going to be 0. So cotangent of pi over 2 is equal to 0. I'm trying to remember from a couple years back, like I'm not too sure why I did it this way. You know what, let's just go, oh, we don't even have cotangent, that's fine. We just gotta go 1 over tangent of pi over 2. Oh, and then we got to make sure that we are in radian mode. Okay, so that's good. Okay, so cotangent is 1 over tangent. Yeah, so something happens. That's why I did it this way. So something is happening with the domain radian mode, tan of pi over 2 degree mode. There is not a lot of the function of the command. So I'm not too sure what's going on. So okay, now I know why I did it this way. Okay, or maybe I was supposed to put parentheses. Let's try that one. 1 over parentheses 10. Maybe that had to be it. I don't know. Okay, well, you're gonna have to help me out on this one. I'm pretty sure there's something somewhere on YouTube land that will help me fix this. Okay, but anyway, cotangent of pi over 2 should be 0, or is it? You know what? Oh, you know what? Don't we have I see now. Can we take a look at the graph? Let's go take a look at the graph. No, we're good. It's at every pi. Yeah, every pi is the asymptote. No, we're good. We're good. Okay. We're good. Okay, so I guess if anyone could explain to me why that's happening on TI-84 plus CE, maybe, I mean, you know, we'll figure it out. Okay. Anyway, last but not least, 61 secant of pi. It's going to be 1 over cosine of pi. Cosine of pi, 180 degrees is -1, so this is going to be -1. Secant of pi. Okay, I think I have one explanation as to why it's happening, and I think it's because on your calculator, pi over 2, I think what's happening is we already know that tan of pi over 2 is undefined. There's an asymptote over here. So I think what's happening is the calculator is calculating this, and it's saying it's undefined, so this means that like we can't even calculate it anymore. And I think that's what's happening. But we do actually have a value for cotangent, so that's why I've done it that way on 59. So anytime you're at the 90 degrees or 180 or 270 degrees, see if you guys can split it up by using the definition, because what you see in the calculator, this is probably not going to calculate it at all. But I think if we do cosine over sine, it should work. Let's try that one out. Cosine of pi, yeah, this actually should work. Divide by sine over pi over 2. Yeah, so that works. Okay. Even though, yeah, it's a little bit weird. Even though that's the same thing, I now can see the downfalls of the TI-84. Yeah. Because it's already calculating tan of pi over 2 is undefined, then the calculator is probably saying, well, the rest of the thing is undefined. Which I can see how that works. Okay, so just be careful. I think it's just better to split it up when you guys are in those degrees. All right, you guys, that's it for the today's video.